to the galaxy. Oh, whatever. But they make a comment on that the definition of the universe basically is so vast and matter is so small and life is so insignificant as to be that the universe is totally uninhabited. Because on average it's, things like that. So actually the movie was horrible. It wasn't a Disney movie, but the movie they made from it was horrible. It was one of the worst movies ever made. The Hitchhiker's Guide to the Galaxy is like one of the worst movies, but the books are really good. It was one of those movies that it was very hard to make a movie from. It's a great book. You can't make a movie from it. It's kind of like Battlefield Earth. Great book, horrific movie. Shh. All right. Now, let's look at a couple of problems. Now, this problem is actually, we're going to do this problem twice, but we're going to look for two different things here. Also, keep in mind that all temperatures, we'll talk about temperatures, all temperatures are in Kelvin. All temperatures have to be in Kelvin, so if you have to deal with the temperature. So first of all, I want you to look back in your notes. These are notes we took today, some of the formulas we took today. Look to see if you can find the answer. It says a heat engine inputs 350 watts of heat energy at 450 degrees Celsius and gets 250 watts of useful work out. What is the efficiency? So work with your partners and see if you can come up with the answer to this, please. In your notes, there are two ways to find efficiency. You have a Carnot efficiency and you have actual efficiency. We just asked for efficiency. So efficiency, the Carnot efficiency is that temperature, TH minus TC over TH times 100%. And then we also have actual, which is work over QH times 100%. So two ways to express that. Carnot efficiency, well, do I have T hot in this problem? Yeah, right? We input at 450 degrees. That's T hot. We would have to convert that to kelvins, but it's still T hot. Do we have T cold? No. Can we use this formula? No. So I go to my next one. Work. Do I have work? Yeah. 250 watts. Do I have QH? Yes, I do. So I can use that. So I have 250 watts divided by 350 watts times that 100%, which is 0.714 times 100%, or 71.4%. By the way, notice the units. Even though we're talking about work and heat, notice we're not saying joules or calories. We're actually calling it watts. This is how it's usually given. It's usually given in terms of watts because it's the energy that's always being injected. Remember, watts, how many joules per second is going into our heat engines. So these energies are usually not expressed in terms of joules, but in terms of watts. And very seldom will you see calories in this type of problem. It's always joules, always watts, kelvins. All right, questions? We already got this down. Again, there's going to be problems like this on the test. They're multiple choice problems, but you have to be able to solve it to find the proper answer. Remember, if we use this temperature, it has to be put into kelvins. Same problem. So you don't have to write this problem down again, but now they're asking, what is the waste heat expelled? So you can just go right below where you did because it's the exact same problem. What is the waste heat expelled now? All right. Now, there are two formulas you guys have QC. That's what waste heat is. We are trying to find QC. Now, you do have another efficiency formula that says QH minus QC over QH times 100%. And we could use this. We just found what the efficiency is. And you would get the right answer. You would work a little harder. I have to admit, you would work a little harder. But there's another formula that has QC in it too. and they gave me the efficiency, but I didn't know work, yeah, I would have to use this. But since I know QH and I know work, I'm going to go the easier route. Like I said, this will get you the same answer, just a little harder. Too much division. So here, if I do my algebra here, I get QC equals QH minus the work. 350 watts minus 250 watts, or 100 watts. Again, formulas in there, having them together, sample programs. All useful on cars, okay? For the remainder of the period. No, you already actually saw the film. You saw that last time.